Welcome to the Walton Pie. Today we're going to be talking about parametric equations. So parametric equations, the word parametric, that comes from parameterized, and so parametric equations are where we're able to write our standard variables, usually x and y, in terms of some other variable. So in other words, we parameterized our variables in terms of another. We were able to write them in terms of another variable. So if we were able to write both x and y in terms of the variable t, that would be one parameterization of x and y. It wouldn't be the only one, but it would be a parameterization. And so that's usually what we care about. We just care about what is one way to write this curve. And so if we have a pair of functions, so we have like x as a function of t and y as a function of t, that would be a pair of parametric equations. So let's say that, for example, we are trying to take our dog to go and play fetch. Your dog is very, very hyperactive, and so he's not going to want to stay anywhere close to you as soon as you take him off of the leash. And you can't really have a dog playing fetch while the dog is on a leash. So instead of trying to keep it on a leash and try and contain it that way, you just used a GPS tracking collar so you could figure out where it was. And so since GPS has latitude and longitude, so we can think of the latitude as like your x-axis and longitude as your y-axis, we could treat the coordinates of the dog as functions in terms of time. So this might be one example of the path that your dog might go running on. So we probably wouldn't be able to write the dog's path as a function of like in terms of just x and y, because this, for example, definitely does not pass the vertical line test. So this definitely is not a function in terms of x. But what we can do is we could write both x and y as functions of t, and that would describe this curve. And so if we were able to do that, that would be writing x and y in terms of time, and so that would give us a parameterized version of the dog's path. So let's go to Desmos to be able to visualize some parametric equations. If you would ever like to do it on your own, the website is on the screen and will be linked in the description down below. So if we are trying to graph some parametric equations, the way we would do it is we write them as an ordered pair. So for example, if we were to want to graph, maybe we have x is equal to t squared, and then y is equal to t cubed minus 5. Let's do minus 1, so it'll show up on the screen. This is one piece of the parameterized curve, but we don't see the entire thing. So if we were to go out to like starting t at -2 and then going to t all the way up to 5, we would get this sort of curve. Now, just doing this is not going to give us very much information, but if we were to, for example, add a slider, so we have maybe something like s squared s cubed minus 1, and then we were to, let's try and get our slider on. Okay, so see how this red dot is traveling along the path? That is the direction that the curve is facing. And so if we were to then have it loop back, it would continue to go along this. So the path is traveling this direction and then goes this way. And so that's one way that we would be able to go and figure out the parametric equation. Now, this is not the only parametric equation we could have. We could have something that's a little bit more complicated. For example, this. This is definitely not a function in terms of x and y, but we can write x as a function of t. So in this example, our function x, let's see if I can zoom in a bit. So our function x is 3t over 4 plus sine of 6t over 3, and then our y function is negative 2t over 3 plus 2 times sine of 5t over 5. And so this is creating these fun little spirals. If we were to modify this a little bit, we would get a different curve. So all of these different ones are different parametric equations. We could maybe say plus 1 or plus 2 there. And so all of these are giving us different parametric equations. Now, some fun ones to do are to have both x and y as functions of sine, and have them both go scalar like that. So this is one parametric equation. Now, what we might want to do is we might want to ask ourselves, what direction does it travel? And this is the nice thing we can do with Desmos, is if you have this one as your function, so our functions in terms of t, and then we just have our bounds, so we are having t go from 0 to 10 pi. What we can do is we can also do something in terms of another variable. So we wrote the same thing with both t's and s's, and then we're just labeling this one with a little point. What we can do is there's the option of what are called sliders. And so what we've done is I've said, okay, just only keep going in one direction. I'm going to have it go fairly slow so we can track its movement. And then we are just saying, let it go from 0 to 2 pi, and we are going to have its steps be in very small increments of pi. So when I click play, it'll start to travel along the path in the direction and the order that this path would be traced according to this parametric equation. As t increases, it'll follow this path of this dot. And so this is a parametric representation of this sort of thing. Now, what gets really fun is if you modify these values inside sine, so for example we change it to like 9t and 9s there, this is not quite as fun looking of a graph as if we were to replace it with, I don't know, let's say 17t. And so if we replace this with 17, let's make this 6 a little bit more fun as well, so let's make that 16. This is some really weird, I don't know, for me it looks like a pillow, but this is a really cool parametric graph, at least in my opinion. I hope you find it as cool as I do, because this is fun. And we can look at this point, and it's slowly going back and forth, and it is getting closer and closer, and now it's going the other direction. And so we're able to figure out a lot of information about this using Desmos. And so this is a really powerful tool if you're ever trying to graph something parametrically and you're just having a really hard time figuring out how to graph it. And so this is how I use it a lot to be able to figure out these sorts of graphs. I hope this video was helpful in getting you a little bit more acclimatized to being able to see parametric equations and get an idea of what they sort of represent. If you did like it, please like and subscribe so that I can continue to make these videos. I hope you have a great rest of your day, and good luck with the rest of your math.